Hey everybody, it's Matt from Eastwood Company and welcome to another technical video. Today we're going to be talking about MIG welding sheet metal. Probably the biggest thing that people do, at least in automotive hobby, when you get a MIG welder is you want to fix some rust, you want to do some sheet metal welding. Unfortunately, it's probably one of the most difficult things to do. We see a lot of guys struggling with blowing through panels and getting some improper repairs done on their car that aren't structurally sound. So I'm going to give you some tips and tricks, show you what it's supposed to look like, and maybe give you some idea of some cool products that are going to help you get your welds and your repairs looking a lot better. So let's dive right in. So with sheet metal welding, there is two wires that I would suggest to use. I would not suggest to use flux core welding or wire when doing sheet metal work. I know some people do it. They get by, but it is not good. Inherently, flux core wire is thicker just because of the flux that's around it. It generally takes a little more heat to melt the wire because it is thicker, which puts more heat into the panel and causes issues, obviously. It causes more warping, causes more grinding. I don't suggest doing that. I definitely suggest, first of all, using MIG welding with a shielding gas. The wire, an 023 wire is probably, if you're doing thin gauge steel, like 20 gauge or 18 gauge, you're going to be pretty good with 023 wire. You can get away with using 030 wire. You just have to change your settings a little bit, but it can be used. The nice thing about the 030 wire is that you can then use it on a little bit heavier stuff, 16 gauge, 1/8 inch, and some heavier fabrication. So it's a little more versatile. That's what I have in the machine today is 030 wire because we use this machine for everything from doing sheet metal welding all the way up to some medium duty fabrication. We're also using the MIG 175 today. Again, because it's so versatile, it's 220 only, but you can use it on sheet metal all the way up to some heavier fabrication. We do offer over here 2 additional machines that we have. We have the MIG 250, which is a much larger unit for heavier fabrication. But again, it can do sheet metal no problem. You can dial it down. Or the 135 is a good little workhorse. It's a 110 voltage machine, and you plug right into a normal house outlet. You can do medium duty fabrication with this, but it's also great for sheet metal welding. I keep a 135 on my cart with just 023 wire in it for when I'm doing sheet metal repairs, and it's great to roll around and use it for that. So that's a breakdown of the machines. The key with welding with sheet metal is that you want to be hot and fast. You want to be in and out of the panel as quick as you can be. So a mistake I oftentimes see is that the beginners, they turn the machine down too low. The actual heat coming out of the torch or your weld is too cold. They think by turning the machine down, it's keeping the panel cooler. Well, you're not really getting the penetration that you need, and it takes more time to create that puddle, which in the end, you're putting more heat into it. So I like to turn the machine up a bit higher. Since I'm a little more experienced, I like to turn the machine up almost to the border of blowing through, but I got it to the point where you can hit the trigger and get in and out real quick, and you're not causing any issues. The other thing, ideally, is you want to get 100% penetration between the two panels that you're welding together. I have one here that I'll show you guys. So we're going to do a little bit of welding later on in the video. We'll see if Joe can get a shot of it. But this is the back side of this piece here. And you can see that on this one here, actually all of them, but especially on this one here, there's 100% penetration. So with that, we know that our weld is connecting both of the pieces and is going all the way through the two panels that we're welding together. Because of that, you can then blend the top edge. You can grind sand and smooth everything out, and you're going to get a nice solid repair because it's all the way through the panel. It's not just sitting on the top, floating there, and when you grind it, it's just going to break or fracture. So you want to be hot, and you want to be quick when you're doing your welding. You want to be in and out as fast as you can to get the heat in there and get the heat out. The other thing is when you're setting the machine up, it's good to get a test piece in the same thickness that you're welding. So before we started this video, I got some test pieces of 20 gauge, and I kind of played with the machine to make sure I had my optimum settings. You definitely want to do that before you're doing a project on your car. Even though I've welded 20 gauge sheet metal countless times, I still like to do it ahead of time, just so you know where your settings are going to be. You never know. Every machine's a little bit different. Every piece of metal is a little bit different, especially on an old car where you got rust and maybe some older metal that's a little thinner from sanding or things like that. So that's the basic idea of what we're doing today. I'm going to show you the two ways to set up a sheet metal repair, to set up your gap when you're welding. With MIG welding, there's kind of two schools of thought. The first school of thought is if you have two panels like this, you leave a little gap in between. So you can see that there's a small little gap in between the two of these. So this is one school of thought that does work. It works well if you get everything set up right. These cool little clamps we have here, these are our little panel clamps. These guys have a little bar here that comes out and has a little thumb screw on the top that you can tighten, or wing nut rather. And this is what it looks like all mocked up. So you can see on the bottom here, when you put this bar on the underside, when you tighten the wing nut up from the top, it pulls everything together, makes the panel flush, but also this little piece here in between sets your gap. So it gives you a little bit of distance between there to set the gap when you're welding a piece together. This is great for creating a consistent gap throughout the whole entire panel that you're repairing. These little guys are pretty cheap and affordable. I usually get a couple bags and throw them in my box and keep them around so that you can you can do a small repair or a large repair if you're doing welding in this manner. So the idea with welding with a gap like this is that, again, we're talking about 100% penetration. Well, by leaving that gap there, you give a space for the wire to kind of go through and fill up a gap so that you can actually bridge that gap there and get 100% penetration. It does work, and a lot of guys prefer to do their repairs this way. The only downside I would say to this is because of that gap, it can be very difficult to fill across that with this thin of sheet metal. And we're going to show you in a moment what a technique that I do to try and help with that. But it is difficult. If you get it not right or your heat's not quite right, you're going to probably burn a hole through here. You're going to create a bigger hole, and then you're going to have to fill that hole and backstep and everything to fill it in. So it can create a mess if you don't have everything just right. So that is one problem. So what I'm going to do is I'm going to set up the machine here, and we'll do a couple stitch welds on this and show you what it looks like after I do a couple zaps here. And we're going to do it just straight up like it is, and we'll go from there. So make sure I wrote all my settings down ahead of time just so we weren't fooling around with the machine. So got set right about there. We're good. We'll make sure that our gas is on. We're using a CO2, a 75-25 argon CO2 blend. Pretty standard. And let me grab a set of gloves here, of course. We don't want to burn our hands. All right. So we got our machine set up. One thing to mention is a mistake that I see beginners make is they leave too far of a stick out on the coming out of the tip of the nozzle here. If you have a real long stick out, maybe something like that, or you hold your hands too far away, it's going to you're going to lose some power by the time that you actually get this gets to the piece. You can also lose shielding gas. So I suggest using a set of these pliers. A little trick that I do. So I use these pliers here. I'll run a little bit out so you can see. I use these little MIG pliers like we sell, and I use the cutter side as a depth to set my depth here. Whoops. I'm gonna flip it around. You set your depth. You cut your piece off, and that kind of gets you close every time. If you want a little bit closer of a cut, you can turn it the other way. But that's usually how I do that. Really handy. These have pliers on them. They have cutters on them. This kind of handles everything on all-in-one tool for using with your MIG welder. I keep one in the cart, and I keep usually one under the flap on the machine. So I have my my ground clamp on the table here. This is a nice, clean, bare metal welding table, so we can clamp right to the table, and we don't have to worry about getting the clamp in and in the way. If you don't have a clean piece, you need to clamp right on the repair area or close to it. If you're working on a car, you may need to sand some paint or some primer or whatever off of the panel and clamp as close as you can to it so you get a good ground. That's very important as well. You're not going to get a good weld if you have your ground all the way across the vehicle, or if it's clamped on an area that's not clean bare metal. So we got our ground clamped on there. We're going to set this piece up here. Move that over, and we're going to do a weld real quick. See if we can get this to go with a gap here. See, that's what happens, and the reason I don't really like the gap portion, or at least without using something to help. You can see when you set your weld there, it blows right through. It's not really a great experience, and now you gotta fill that hole. So what you really need to do is you need something to back that up. Now I can quick do a weld here and blend that in, and it'll be just fine. But it's going to be more heat into the panel. To save yourself the hassle, what I like to do if I have to weld with a gap like that, or if I have to fill a gap with a MIG welder, is you can use these copper backers. We sell a kit that has a little handle with a bunch of different sizes, or a bunch of different shapes at least. And then we also have these flat ones that have some little magnets on them. For this instance, a flat one would be great. I'm just going to put the flat one behind here. And since we got our clamps on here, I got to set something underneath. But I'm going to use that to back up my weld, and let's see what it does with the copper backer attached and see if it's a little easier. Now I'm going to take this off here. Sounded a lot better, right? So that's the difference between welding. And that's the one without the backer. It just blew right through. And again, I could probably finagle it and get the thing to weld, to get it to weld without the backer on there. But it's pretty tricky. It takes just the right hand movement to get it set right. Versus using the copper backer, boom, I put it on there and I just did a quick weld. Now, one thing you may have noticed, I don't know if it was easy to see when I did it. When I do welding like this, I like to. It doesn't really matter how you do it. I usually will kind of sit. I'll kind of sit the edge of the nozzle down on the piece like that, so I can get a visually see where I'm welding. And then I just right when I'm about to weld, I lift my hand up off of the piece. And I hit the trigger while my torch is still turned like that. And then as soon as I see that puddle form, I turn my wrist up like this, over to the other way or straight up and down. What that does is you're kind of wicking the puddle from one side over to the other. And it really helps kind of just fill the puddle out, get a nice flat weld. So that's one trick that you can do. Or if you're trying to fill a hole like that, you can kind of do the same thing where you can favor one side and then quickly move it over. You will also notice I was on the trigger really quick. There wasn't a long weld. It was just zap, in and out, done. Well, if you got the machine set correctly, it'll be nice and hot, and you'll be in and out, and we don't have excessive heat into the workpiece here. Now, the one thing you will see on the back side here, if you look, this is the back side. We got 100% penetration. It's completely filled up that gap there. So that's what you want. Now you got 100% penetration. When you sand the top of this smooth, you're going to still have something bridging the gap there, and it's still going to be nice and strong. So that's without or with a gap. That's one way to do it. You just got to make sure you set your gap like that. And again, I would highly suggest one of these copper backers. The other way is to do it like we showed in the beginning on the piece with no gap whatsoever. So this piece here, I butted it together tightly. I've put some tack welds on it just to hold it together, so we can easily show you how it's gonna weld. With this way, again, nothing wrong with this. It's just that you need to set the machine up so that it's a little hotter, because you're melting between the two pieces to join them together, and you're almost melting that center area away. So with that, we're going to crank the machine up a little bit. So we're going to crank it up basically a whole entire setting and 1 wire speed. I'm sorry.